Now in this video we are going to study a topic called resolution of vector. Now if you remember in the previous videos we studied a few things. I'll just quickly recap. The two things were that we studied triangular law of vector addition, which was like this: if this was A, this was B and this was R, then according to this law it will be R equals to A plus B. This was the triangular law of vector addition. Then we found out the magnitude of this R by using the formula A square plus B square plus 2AB cos theta, and we found the direction, which was B sin theta upon A plus B cos theta. So these three particular concepts we did in the last video. What we did here, now listen very carefully, what we did here, we took two vectors A and B and combined them to find out this one vector R. In resolution of vector, this procedure is reversed. That is, we have one vector and we are going to split it into two. Here we had two vectors A and B and we added them to get one vector. Now we will have one vector and we are going to split it into two vectors. So that method is called resolution of vectors. The splitting of one vector into two components is called resolution of vector. In your syllabus, according to your syllabus, those two components will be perpendicular to each other. So the components will be rectangular components. Rectangular components mean which are 90 degree to each other. Rectangle has 90 degree between each side. So rectangular components, the two components vector which have 90 degree between them. Before coming to the formula, let me tell you, because now we are splitting them into 90 degree, so using axis becomes easier. Now this will be like this. Now if we have any vector, if we have any vector which is only along x-axis, or which is only along y-axis, or which is only along z-axis, then its direction can be given by a unit vector. We studied unit vector whose magnitude is 1 and whose direction, which gives the direction of a particular vector. We used to denote unit vector with cap. So if a vector is only along x-axis, then its unit vector will be I cap, small I with a cap over it. I cap is the unit vector along positive x-axis. Along negative x-axis, it will be simply minus I cap. Similarly, along positive y-axis, the vector will be j cap, small j with a cap. So j cap. Towards minus y-axis, it will be minus j cap. Similarly, towards positive z-axis, it is plus k cap, small k with a cap, small k cap, and towards minus z-axis, it will be equal to minus k cap. So we are going to use I cap, j cap, and k cap for x-axis, y-axis, and z-axis respectively to find the rectangular components. What does this mean? This means that if I have a point, if I have a position of a particle, let us say this, A is the position of particle and its coordinates are given as 3, 2, 4. X coordinate is 3, Y coordinate is 2 and Z coordinate is 4. Then I can use the method of position vectors which we studied, RA, to define this position of particle A. How to write this vector? This vector will be written by using these three coordinates and I, j and k cap. 3 is the x coordinate, so it will be 3 I cap plus 2 j cap because it is along y axis, and 4 is z coordinate, so it will be 4 k cap. So this is how you will convert a given position into position vector. Now it is in vector form. Each of the coordinate has its magnitude as well as direction. Its direction, magnitude of y-axis, and its direction, magnitude of z-coordinate and its direction. So we have converted position into position vector. This is how we convert a given scalar quantity into a vector quantity. If suppose this was 3 minus 2 4, let us say these components were 3 minus 2 4, then it will be 3 I cap plus 2 into, it will be minus j cap because of the minus coordinate. So this minus will come out and this will become 3 I cap minus 2 j cap, 4 will remain as it is, plus 4 k cap. So this is how we are going to do this. Now let us come to the resolution. How do we resolve a given vector into rectangular components? Okay, our syllabus is concerned with rectangular components only. So we have a vector, a resultant vector is given to us like this, OR. This is the resultant vector, and let us say we used angle beta, the angle between resultant and any one vector. We used angle beta, so we are going to use same thing. Okay, so there is no confusion. If the resultant vector, if this given vector is making an angle beta with x-axis, then to resolve this R into two rectangular components, what we will do? We will make one component along x-axis, one component along y-axis. Rectangular component, so that the angle between the components is 90 degree. So let us say the component of R along x-axis is Rx, the component of R along y-axis is Ry. Let us say this. We make a parallelogram, a rectangle or a parallelogram. Now if we know that in a parallelogram opposite sides are equal, so if this is Ry, then this will also be Ry. Okay, now we take the triangle with this triangle. We are taking this triangle, the lower triangle, and if we find sine of beta, then it will be equal to Ry upon the hypotenuse, which is R. So we can write Ry will be equal to R sine beta. Similarly, if we find cos beta, then it will be Rx by R, or we can write Rx equals to R cos beta. So these will be our two rectangular components along x-axis. Rx is given as R cos beta, Ry is given as R sine beta. Now if we change this beta, I told you that it is not necessary to take beta with this axis only, you can take beta here also. So if you take this angle as beta, then the cos and sine components will get reversed. This Ry will become R cos beta and this will become R sine beta. So it depends upon beta which one is the cos component and which one is the sine component. So you can choose whichever is easier, or you can choose what, to memorize one rule, that with whichever axis it is making angle, that particular component will be the cos component and the other component will be the sine component. So when beta was here, this should be the this should be cos component. So this was here cos component and this was y was sine component. So this is sine component. So you can memorize like this also. Okay. So this will be the Rx and Ry, the two component vectors. So we split R into two rectangular components.